Now here comes the tricky part. We have already said that the matrix A is going to be a third of x1 minus x0, a sixth of x1 minus x0. Here again is a sixth of x1 minus x0, just for symmetry purposes. Now the big tricky question is what is here? Once you figure out what's here, you can pretty much follow the same ingredient to construct the whole matrix.
Twice.
Yes, I heard twice. Yeah. So this term actually appeared twice. This term is what? A1 times A1, right? So A1 times A1 appeared, yes, twice. One is it appeared here when n is equal to 1. It also appeared here, n is equal to 2. So the element there is actually a superposition of contribution from two elements. Okay? And actually, it's not hard to figure out in this matrix how the contributions add up. So, for example, the first 2 by 2 block of the matrix contains contributions from the first element. Which entries contains contribution from the second element? Actually, it's not the next ones, but this, right, they actually overlap on this one.
Oh, yeah. That's
right?
I meant you shift it down.
Yes, it just shifted down by 1. And then the one that contains contribution from the third element is this guy. So this would be the whole matrix if I have 3 elements. There are 2 elements that has contributions from 2 elements. Right, so for example, the one I just put a question mark on should be, let me write green plus red, should be contribution from the first element, which is actually the same as this one, right? But then I need to plus a third of x2 minus x1, right? Which is contribution from the next element. And here I have a sixth, because this only has contribution from 1. And then I have a third of x2 minus x1, and here comes the third element. I think I... Come on. I have contribution from the third element plus a third of x3 minus x2 and a sixth of x3 minus x2, a sixth of x3 minus x2, and a third of x3 minus x2. Right, so here is the entire finite element matrix. Any questions? Yeah, so whenever you do finite elements, your final matrix, so this is this process of adding these sub-matrices into one big sparse matrix is called the process of assembly in finite elements. Always you have one matrix that comes from every single element. Okay? This small element matrix it's usually a square matrix, and the number of rows and number of columns in that matrix is the same as the number of non-zero basis functions in that element. So here, for each element, we have 2 non-zero basis functions. Therefore, each submatrix is 2 by 2. If you have triangles in 2D, each element is going to have 3 non-zero basis functions. So your whole matrix is going to be assembly of 3 by 3 matrices. If, for example, if you are again in 2 dimensions and you have triangles, piecewise linear functions, and you are solving coupled system of 2 equations, all right, you're going to have actually 6 basis functions that are non-zero per element. Because for each equation you solve, each unknown you solve, you have 3 basis functions. So you would be assembling 6 by 6 matrices into a big matrix. All right, and this is something you always do in finite elements, just to put small matrices together to form a huge matrix. Any questions on this part? This is the quadratic part of our energy minimization. Right.